Engineering conversation and innovation. This is Schulich Connects, proudly sponsored by TD Insurance.
Good morning, everybody. My name is Anders Nygren. I'm the interim dean of the Schulich School of Engineering. And I hope everyone has had a good summer, some chance for some rest and relaxation with friends and family. And it's really good to see you all here for the first Schulich Connects event of the season, entitled Engineering Innovations to Combat Climate Disasters. This event is proudly sponsored by TD Insurance, and I'm really happy this morning to have Trina Vanderhorst, Max Stiles, and their team from TD Insurance with us here at the Dean's table at the front, so welcome. I'd like to start, before we go further, to start by acknowledging and paying tributes to the traditional territories of the peoples of the Treaty 7 region here in southern Alberta. So this includes the Blackfoot Confederacy, comprising the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda, including the Chiniki, Bears Paw, and Good Stoney First Nations. And the city of Calgary is also home to Métis Nation of Alberta, Districts 5 and 6. So as climate change intensifies, the need for innovative engineering solutions has never been more urgent. We must explore and develop cutting-edge technologies and strategies to prevent and mitigate and respond to the growing threat of climate-related disasters. And the need for these technologies and strategies has really been evident close to home recently. So thinking of the devastating impacts of disasters like the 2013 Alberta floods, or the 2016 Fort McMurray wildfire, or more recently the Jasper wildfire this summer. Our panel today will explore how engineering can be a force for resilience in designing a safer and more sustainable future. And before I pass it over to our speakers, just some logistics. There will be a question and answer session at the end of this program. So please hold your questions until then, and we will have somebody bring a microphone to you if you wish to ask a question at that time. So I'd now like to introduce you to Dr. Alex Ramirez-Serrano, today's moderator. Dr. Ramirez-Serrano is a mechanical and manufacturing engineering professor here at the Schulich School of Engineering. He performs research and development activities focusing on ground and aerial unmanned vehicle systems. And he is also the founder and CEO of a company called Forefront Robotics. And this Calgary-based robotics company develops highly maneuverable drones and custom unmanned vehicles for deployment in confined spaces such as collapsed buildings. So I'd like to pass things over to Alex, who will introduce us to today's panel. So Alex, over to you.
Okay, thank you, Anders, and nice to see everybody here. Welcome. If you haven't been to Schulich, welcome to Schulich. So as Anders said, thank you for the introduction. My name is Alex Ramirez-Serrano. I work in the Department of Mechanical Engineering, and I have been involved with search and rescue robotics for a number of years. I have worked with the Department of National Defense. I have worked with something that we call here in Canada, the Canada Task Force teams that provide assistance when disaster strikes, tornadoes, floods. We just had the forest fires in Jasper. So I have been working on this area for a number of years, trying to develop tools and technologies to keep people safe, first responders safe, to save infrastructure sometimes, and there's a myriad of artifacts and things that are needed when disaster strikes. So that's just me, and for me this topic is really interesting. So we have a great set of panelists here that are gonna just provide us with a little bit of the tip of the iceberg of all the challenges that exist in this area. So yeah, with that said, I'm just gonna introduce our three panelists here. And I'm gonna use my notes here. The first one is Sandy Cummins. Maybe if you can raise your hand. Thank you, Sandy. So Sandy holds a bachelor's degree in civil engineering here from Schulich School of Engineering. And over the past 34 years, he has provided civil engineering advice and assistance to national parks and historic sites in Canada. So all the way from the West Coast, almost to the border across close to Ontario. He has also developed an asset management system, modernizing how Parks Canada tracks its vast array of infrastructure, from buildings, asset management, technology that they use to manage parks. Also, he has a vast array of infrastructure. and knowledge in how to help Canada Parks manage disasters once again. The next one is Dr. Shabnam Jabari. So Jabari teaches, is associated with the University of New Brunswick. So thank you for traveling all the way here to Calgary to be with us in our panel. So she's with the Department of Geodesy and Geomatics at UNED. She received her PhD from the University of New Brunswick. She works on 3D information, supported urban change detection, and multi-agent sensor images. Her work has resulted in a number of advances, including a patent technology. Her interests are in artificial intelligence, urban digital twins, urban areas change detection, and multimodal mapping. She focuses her research in applying artificial intelligence and geospatial data to climate change. So thank you for being here. And our last of our panelists is a colleague of mine. He also works in the Department of Mechanical Engineering, Dr. Skyler Hinman. He has been with us for a number of years. He works on computational fluid dynamics to study and advance next generation of aerospace and green technologies. Dr. Skyler, or Dr. Hinman, completed her PhD here also at the University of Calgary. So we're actually promoting and generating the next set of people that is solving our needs and challenges. So anyways, Dr. Skyler completed her PhD here at the University of Calgary in 2017. And before taking the position here at Schulich, he worked with Atlantic Research Labs, working in the aerospace and green technology divisions. And he has been with us since 2021. So thank you for all our members in our panel just to be here in this discussion. So with having said that, I'm just gonna maybe start with the questions. So the first question is gonna be about climate change. As we know, climate change has been changing, and now we have been seeing that natural disasters happen more frequently, more potent, and they cause more disaster, and more people are affected. So maybe the first question would be for our guest visitor from New Brunswick. So the first question will be, what are some of the latest engineering technologies being developed to mitigate climate change disasters, particularly wildfires and floods?
Thank you very much, Alex. Thanks everybody for coming here. It's a pleasure to be here. I'm a geomatics engineer. My background is in mapping, so I can speak to the mapping set of applications of engineering. So one of the things that we do for climate change is to produce a very detailed base map for the urban areas, for forests, to be able to model, simulate the upheavals, and also be able to make the preventative actions. So one of the things that we currently lack in Canada is producing a 3D model of the whole urban environments that we have, because that's where most of the heat is actually coming from. Urban areas are contributing the most to the heat and producing more heat, and especially considering urban heat islands. They contribute mostly to the climate change, so having a base 3D foundation model there is a necessity, and unfortunately in Canada we still do not have those what we call urban digital twins. They're being really well developed in European countries, and they are already in implementation. But not for Canada yet. Well, considering the vast urban environments in Canada, Canada is such a big country, so modeling the whole country in a detailed 3D environment is very challenging. So what we're doing in Atlantic Canada, particularly in New Brunswick, is just to produce those 3D models. And in the city that I come from, Fredericton, we have a beautiful river, St. John River, that looks so nice and calm, but in almost every April, May, we get the water level slowly rising up and flooding all the core downtown parts of the Fredericton, and that causes a lot of damages to the infrastructure, to the roads and buildings. So we are working on creating a digital model of that. We're cross-referencing them with the water level and with river watch efforts that we have in New Brunswick. We can model how high the water can go, and so that we can produce a detailed 3D model of seeing which buildings are going to get flooded if water level rises up to this much. So that's one of the things that we're doing, particularly in my lab.
Thank you, Jabdan. So very, very interesting topics, very, very challenging aspects. My next question will be for Sandy. You have been helping Parks Canada manage their assets, and maybe you can talk to us a little bit about what engineering technologies or tools need to be enhanced to save more lives and protect infrastructure when disaster strikes.
Thank you. Yeah, within parks, we're looking at the climate change and the impacts not only of forest fires, but of the climate in general, looking at how our assets respond to that and how we can adjust them. The 2013 flood really was one of the important sort of events that caused us to rethink how we look at designing some of our heavy infrastructure and that sort of thing. The whole idea of having a 100-year flood model really got turned on its head with that event and some of the other events that have happened since then, and using that as sort of the benchmark to design for our roads and our culverts and bridges and that sort of stuff really got switched, because we had to think what now was the 100-year event become the 10-year event. And that really changes how we look at modeling and how we look at designing our assets. And that caused a whole rethink of, do we have the right size culverts in our roads? Do our bridges the right size? We lost 60% of our bridges in the Western National Parks alone from that one event. And that caused some very significant issues for the national parks in Western Canada, especially in the mountain parks, as to how we deal with that. From the other asset perspective, we're always looking at how we can protect our assets not only from changing environments, but also from fire, wildfire, and that sort of stuff, as was exhibited in Jasper, this most recent event. We've taken a look at and are now making active changes to switching over a lot of the construction materials that we use to looking at how we can get more fire-resistant materials into our assets, as well as the existing assets. Are they fire resistant? And if not, in the recapitalization process, switching them over to, like, for instance, in a lot of the mountain parks within the own parks infrastructure, a lot of the roofs were either asphalt tile or cedar shake, which doesn't survive very well when you get into a fire situation. So one of the pushes has been, when we are having to do our recapitalization or these structures need repair, well, let's switch them over to metal roofs. Let's switch them over to more fire-resistant materials that will resist sparks and resist embers a lot better than what we've seen in the past. And the other big thing that's been looked in is looking at how to fire smart all of our assets and that sort of stuff. And that's become a really big focus over the last number of years.
Yeah, thank you, Sandy. A very interesting topic once again. Just a quick comment as for those of you who might not know, after this disaster strikes, according to statistics around the world, a community takes between 20 and 30 years to recover. We just had the forest fires in Jasper. We don't see those ones in the news anymore, but they're still recovering, and they will probably still recover for a number of years from now. My next question will be for Skyler, talking about forest fires and Parks Canada. So my next question for Skyler will be, how can engineers contribute to reducing the likelihood of future wildfires and floods in Canada? I know that you have been working with developing advanced aircrafts for forest fires, mitigation or prevention. So maybe tell us a little bit about that aspect.
Yeah, so with drones, they present a good opportunity for surveillance and mapping, so they can sort of enable some of the other technologies the panelists have talked about. Another element that specifically, because I'm interested in aircraft systems, is in prescribed burns. So if you want to start prescribed burns in a safe and managed way and monitor them as they develop, drones can also support that. There's NASA has a working group called ACERO, and it's advanced capabilities for emergency response operations. And so it's a task force within NASA that's been specifically started to look at ways where these types of aircraft systems can support this problem. And one of the first things they're looking at is that prescribed burns and also sort of situation monitoring, because aircraft that can stay in the air unpiloted for very long periods of time present a good asset in that vein.
Okay, thank you, Skyler. As you can see, all these things are involved with not just preventing and responding to disasters, but it's also affected by many things such as climate change. So my next question probably will be for Shabnab. So given the increasing frequency and intensity of wildfires, floods, and other natural disasters, such as climate change or due to climate change, how should the engineering profession evolve to address these challenges?
We definitely will need more interdisciplinary work for combating climate change, because climate change is a topic that requires a lot of expertise, like mechanical engineers, civil engineers, geomatics engineers. We produce the base map. The other engineers can also help with designing aircraft systems and such. I think in engineering, particularly in academia, we tend to get into our silos and focus on one deep area and then proceed with that. But as we expand our vision and then look at the bigger problem that is climate change, we tend to realize that more interdisciplinary research is needed. So we need to, as an educator in engineering, I take it upon myself to provide that expertise and then provide that background to my students to be able to work with other engineers on combating climate change. Particularly in mapping environments, we see a lot of folks from geography, we need to work with folks from forestry, and also with hydrodynamic modeling, particularly for flood mapping. We will need to work together. What I do in my lab is to bring in experts from other areas, those who can do hydrodynamic modeling of water, which is not my area, and I bring mechanical engineers, I bring civil engineers to my research teams, and we work together on the same topic of modeling flood levels, because I understand mapping. They understand how the water hydrodynamic and hydrologic models work, and we work together to provide a solution for that. So I think one of the key aspects of this would be definitely more and more interdisciplinary research, particularly in the face of AI, that like we all hear about it, like we basically nowadays, maybe even daily, have a daily interaction with AI. So that requires definitely more interdisciplinary research in this area.
Thank you, Shabnab. So once again, very interesting topic. Just a little piece of information for you once again. For those of you who don't know how first responders operate, they just don't go to the site and respond to the situation, but they have to collaborate, as the panelists were saying, with mechanical engineers, structural engineers, EMS, police, firefighters. All those individuals have to be involved. So my next question on that topic is going to be for Sandy. So my question will be, how can engineers collaborate with other disciplines such as forestry, meteorology, and urban planning to create a more integrated approach to managing climate change and fighting disasters?
That is a very interesting topic, because it's becoming more and more important that we do have that collaboration. And the biggest thing I think is to look at, especially for us in the national parks, is a collaboration between all sectors to be able to take this information in, and we're starting to do that. to be able to incorporate it into looking at a particular problem or a particular design. One of the things that we have found recently that there's a lot more cooperation going on between our consultants, who are primarily the designers and that sort of stuff, and the environmental specialists that are in the individual parks that know the conditions in the parks, that are now trying to adapt the design to match the requirements that are placed in the park to meet the environmental and the climatic side, which don't always tend to want to work with each other. There's a very, you'll see this in just about any industry, silos created as this is my space, don't play in here, versus this is my space on this side, between the environmentalists and the engineers and the architects and all this sort of stuff. And what's really been happening lately is a collaboration of all of this, simply because we have to work together and we have to move forward. And a key example of this, I guess, to bring forward is a project that I worked on in Saskatchewan that had to look at not only the environmental side of things, which was the species at risk. This one particular site had, I may be wrong, but 8 separate species at risk that we had to deal with to put this road through. We also had to deal with the conditions for the storm and runoff, which was because the soil was very prone to becoming, I don't know if you've ever heard of the Saskatchewan muck. It's terrible stuff to work with. And then we also had to deal with the climate that with increased rain and wind and that sort of stuff, to design and implement a road that addressed all of these things. And we came up with a design through our consultants that was very unique and has not been done before, and has proven to be very, very effective in that park with reduction to the species at risk, as well as dealing with the environmental conditions. And these are the types of things that we have to promote within the engineering and other disciplines, is this collaboration. And if we don't have that, we're not gonna make it.
Thank you, Sandy. Once again, very interesting topic, very challenging topic. Just another piece of information for you. Usually, for example, when a building collapses, how many times do you think a building is inspected? And I'm not expecting an answer for you, but on average, based on the statistics, a building is inspected about 6 to 7 times. Civil engineers go and inspect it, first responders go and inspect it. So it's a challenge. The communication and things that these teams have to have is a real challenge. So we just have touched the tip of the iceberg, but right now I'm gonna ask my last question, and then probably we open the floor for questions. I'm gonna be asking a question for Skyler, since he works with technology. So my question to Skyler will be, what new engineering technologies would need to be developed to keep first responders safe? It's an example of when we access a collapsed building, when we go to a forest fire. What new technology do you think, and maybe then I open the floor for all the panelists to comment, what technologies need to be developed to prevent putting first responders in harm's way and saving lives?
So I guess generally, I would say anything that can, because I work in sort of remotely piloted, my brain automatically goes there. But anything that can reduce the workload on the first responders, when you can have something that's automated or robotic take some of the workload from them. Also, any sort of technology that can enhance their awareness of the situation around them. So if you can bring something with you in your backpack, like a quadcopter, put it up in the air, survey immediately the situation around you in real time, that can be a huge asset. And then really important in my domain, for first responder safety, like one of the biggest barriers for broader adoption of remotely piloted aircraft is actually air traffic management. And that's a legislative challenge. Putting remotely piloted aircraft in the air with piloted aircraft is, it's a scary thought for a lot of pilots, and it's a big challenge. But Canada is really good on this. people working really hard. There's been 2 consortiums in working in Alberta on what we call BV loss, which is beyond visual line of sight, and that's to work on developing the legislative framework that allows this to happen. So what kind of systems do we have to require remotely piloted aircraft to have so that they can be in the same airspace as piloted aircraft, so they show up on each other's radar, they can avoid each other, something like traffic collision and avoidance. So there's a software element, there's an avionics element, there's an aircraft design element, and that's like really the big challenge. Like making a new aircraft that can do X and Y is an engineering task, but right now the major blockade is how do we do it safely to keep pilots comfortable sharing the airspace. So right now, like the first thing that could happen right now is that they don't share airspace. Maybe remotely piloted aircraft can fly at night when it's not safe for first responders to do. I went, one of the air attack officers in Alberta wildfire showed me a video out of their cockpit when flying at night, and it is like pitch black. So you can imagine that it's an unsafe time to operate a piloted aircraft. So, but you don't need, the whole idea of beyond visual line of sight is there's no line of sight, it's operating all on sensors. So the legislative framework, the technology for that, the software, all that is being developed now, and actually Alberta is actually really good in that area too. So I'm sorry that I always, my brain, maybe that's not very interdisciplinary of me, but my brain always goes to what I know, which is the aircraft side. So.
Thank you, Skyler. Once again, very interesting topics and challenges. So we're running a little bit behind time. So right now I'm just gonna open the floor for questions. So I believe there's a mic floating there. So if you have just a question, just please raise your hand, and a mic will come to you. Any questions from the floor? And please feel free to direct your question to a specific panel member, or maybe just make it generic. Go ahead.
Question for anyone, I guess. Have any codes or standards been updated to match the new climate probabilities and severities?
I can take a run at that. The National Building Code is making some changes. We have seen in the latest update that I think we're now under the 2020 code. There was some changes to look at wind speeds and that sort of stuff, as well as other climatic things. They always now are incorporating that into the building safety side because of recent events, and you'll find that any changes to the building code is usually a result of a disaster that's resulted in loss of life. So there are changes happening. I'm just not aware fully, but I know in the last update of the National Building Code, there has been some adaptation in the environmental requirements that we have to meet when we're designing structures.
Thank you.
Yeah, there was another question here on this table, maybe? Okay.
Oh, hi. I just was wondering, with our immense forestry industry and the need to protect forests, if there's what's being done or what the thoughts are on doing the cutting to create bare land perimeters, which would presumably help inhibit the spread of fires from land to land. It's a creative thought here.
And one of the things you're going to start to see, and I can only speak from my experience with Parks Canada, is that this whole fire smart approach we're doing fire breaks around communities has really started to become a focus. I don't know if you saw in the news, Parks in the last week, Parks Canada has announced that they are starting to do a fire break program both around Lake Louise and Banff. There was a fire break in Jasper, which was effective for the side of the community that it was on. And we did a significant fire reduction program in the Whistler's campground in Jasper, which actually resulted in the campground primarily being untouched. So there is a heightened sort of awareness with the fire smarting, and that's now being looked at in Parks Canada around the communities. But I've also seen that becoming more and more of a focus for a lot of the communities that are in the forest, the boreal forest type area as well.
Yeah, thank you, Sandy. Just a comment on that. Every disaster is different, and I believe agencies have been struggling to come up with regulations and new technologies, because once again, every disaster is different. I'm not sure if you know this, but for example, everybody will know 9/11, right? Some years ago, when the Twin Towers in New York collapsed. So there were a number of victims rescued, but there has been about 20 times more first responders that have died. And that's not a number that is released to the public, but it's because we send these individuals to those spaces, and we don't know what we're going to encounter, what they are going to encounter. So it's a real challenge. So thank you, Sandy, for the answer. But we also, first responders and EMS and police, firefighters, are always changing and adapting. Especially now we're talking about climate change. These things are dynamic. They are changing. And what we saw 20 years ago when this tornado struck is totally different now. Totally different. We have seen, probably you have seen in the news about the hurricane that is going to strike, or probably already did, Florida. Totally different. These are situations that we didn't know could happen 20 years ago. So anyway, so we ran out of time. Thank you all for attending this panel discussion on a very interesting topic. Hopefully you enjoyed your breakfast. So I'm just going to pass it to Anders to give the final remarks. And thank you for our panelists. Thank you, Shabnam, Sandy, and Skyler. Very insightful information. And thank you for just providing us with an insight. Once again, just touching the tip of the iceberg.
Okay, well, thank you, Alex, Sandy, Shabnam, and Skyler for the great discussion this morning. And thanks to everyone in attendance for spending part of your morning with us. I'm sure that the panel speakers will be willing to hang around here for a few minutes if you have additional questions that you'd like to discuss with them one-on-one. I hope you'll enjoy the rest of your day, and I hope we'll see you here for our next Schulich Connects, which will be on October 24th. So keep an eye on the inbox for the invite to that. Thank you again, and enjoy the rest of your day.
Thanks for tuning in to this Schulich Connects, proudly sponsored by TD Insurance. We'll see you next time.